thank you everybody for attending this webinar. So the theme of it is the future of portable gas detection. We've got 4 sections, so we'll do a brief introduction, an intro to the presenters, and a little bit about Crowcon. And then we've got 3 main sections where we're looking to cover off where we think we are, a little bit about where we are today. So at Crowcon, we've put a lot of effort into launching a new range of products. So for us, it's a bit about where we are, but also then looking to where this leads in the future. So we'll try and make it interactive. Laura will be helping there with a bit of a interactive quiz just to get a bit of your feedback. And yeah, so if you've got any questions, drop them in the chat and we'll try and answer them as we go along as well. So firstly, my name's Jamie. I'm the technical director here at Crowcon. I've been here about 3.5 years now. I'm joined by Ben. So until recently, he was a project manager in the R&D team, and he's been responsible in large part for some of the developments that you'll see today. And then also Ed Clapham, who's the product manager for portables, and he's been on this journey as well. And going back 3 years or so, we crafted a journey of how we move forward at Crowcon and bring our portable offering into the present and then looking to the future as well. For those of you that aren't fully familiar with Crowcon, just a bit of background. So we're based here in the UK, just south of Oxford. We've got over 50 years of dedicated gas detection experience, and we're a dedicated gas detection company, so fully focused on gas detection. And the solutions that we provide, we sell them globally, so all over the world, many different applications, many different countries. And we've been doing it for a very long time. And also we're very proud. We've put a lot of industry firsts out there, and we also pride ourselves on making sure that we work well with customers and that people are happy with the products and services that we provide. So paradoxically, I'm going to start with something slightly different. So this is not somebody that works at Crowcon. For those of you that know, this is Jeff Bezos. And there's a quote really that he said that resonated very strongly with me, which is, he often gets asked the question of what's going to change in the next 10 years. And, it's an interesting thing to look to the future, but he almost never gets the question of what's not going to change in the next 10 years. And so when we embarked on this journey of developing a new range, really this was one of the key things that we held in our minds when we were thinking about gas detection. Of course, we want to move with the times and make sure that we're putting, the best technology that we can in it. But also fundamentally, we wanted to make just really good gas detectors. We did a lot of work in the early days going out and speaking to our customers. We wanted to get feedback, find out what they liked about our products and what they didn't. And also, what were they thinking about for the future? And the interesting thing is none of them said these things. So you will never hear a customer saying, please make it less reliable, or it's too cost effective, or the battery's too long. So all of these things, when you strip it back, we're making life-saving devices. And so really there's a level of fundamentals that you just have to get absolutely right in order to make sure that you've got a product for the future. And even though it's not necessarily the exciting part of gas detection, it's the part that makes a difference, and it's the part that saves lives, which is really important to us. For us at Crowcon as well, we wanted to retain some of the the things that we've done well historically. So things like reliability and providing really the right product for the right application. So the first thing we start with is reliability, and we wanted to move this forward. So we, with the new products, we kick the hell out of them. What we'll do is we'll drop a little link in the chat. The engineers made quite a nice video, just looking at how we tested the device. And we know in applications, whether it's wastewater or telecoms or, just general everyday use, that these things get abused, they get dropped, they get thrown around. Oftentimes, the end users, it's not what they are there to do. They're not there to detect gas, they're there to do a job. And so, really, they want the device just to be as easy to use and reliable as possible. And so, what you can see there is drop testing. We know that people throw these things around. So with these new products, we made sure that they went through the mill with the testing, multiple 6 meter drops, and safe to say that it barely had a scratch on it at the end. The other thing as well is resistance to water and dust. We changed how we configured the products with these new wearables, and one of the configuration changes was to have downward facing sensors, and we did a fair bit of user testing with this to make sure that it was acceptable for the different applications and the different customers. But you get real benefits from this. So first of all, it makes it much more resistant to water and dust ingress. If you think gravity pulls things downwards, it means that the those sensors are resistant. But it makes it, from a gas detection perspective, it's just as good. If you think about it in the fixed gas detection world, you already have downward facing sensors. So as gas propagates, it doesn't change how quickly that the device can detect gas. Also, from a personal wearable point of view, you want it as close to the breathing area as possible, hence why you wear it high on the chest. But if you look down at it and breathe on it, it won't interfere with the sensors. So you're not getting spurious readings from people breathing on it. And just to explain, those of you that are familiar with ingress protection, so this is specifically looking at dust and water. So the first digit that you can see there, which is the 6, that relates to dust. And then the second digit relates to water. So IP66 and IP68 are the highest ratings that you can get for a device. And this won't change. So if we're talking about the future of gas detection, we never want to roll backwards from there. We've tested the hell out of it. We've submerged the device, and once you take it out and give it a shake, it's good to go again. As well as the portables, we also have recently released an area monitor. And again, we've applied the same principles, things that won't change. It needs to be rugged, and it needs to be reliable and easy to swap. We know these things get beaten up. We know they get kicked around. And therefore, the approach that we've taken is to try and make the units as serviceable and easy to replace parts that get damaged on it as possible. It's tough by design. So it's got a thick rubber boot, you can drop it. And the orange bit, which is the outer casing, essentially this is a carry case for the detective. Looking at that device itself, if we reflect on where Crocom's come from, we actually created the first area monitor over 30 years ago. It was also called the Detective. We decided to keep the name similar. So we've added the IQ, which indicates it's part of the new range of portables. But we've kept that Detective name because we're very proud of the history here. It's got a long, good history, the Detective. It's been successfully deployed all over the world. And really, we've taken that and upgraded it for modern gas detection. It can handle up to 7 gases. We talked about battery life. One of the key things with an area monitor is making sure that it lasts as long as possible when these things get left out in the field, and you don't want to have to go out and either bring them back for recharge or try and swap the batteries. So it's really important that you push that battery life as long as possible. And it has all of that ruggedness built into it, as I mentioned on the previous slide. And then finally, the bit that kind of ties it all together, again, it relates to the ease of use of products. One of the key focal points of recent developments has been on usability. And a key part of that is making it easy to manage fleets. We have a platform called Crocon Connect. And really what we're trying to do with that is make it as easy and smooth as possible for you to see what's happening with your fleet. So when does it need calibration? Are the devices being used? Does a sensor need changing? Who has the device been assigned to? Where is it? And when do I need to bring it back to base? We really focused on ease of use. So we tried to reduce the amount of button clicks. We tried to make the report generation as simple as possible, and to have online access to all of your calibration certificates so that you can just drag that off wherever you are. You can see there you've got a tablet and a mobile. So this is a platform that you can have, whether it's on your mobile phone. We have a companion app that works with both the calibration station and the devices themselves, or you can put it on a tablet, or if you've just got a PC, you can run it directly from there. So really what we were going for was maximum flexibility and the ability to just have it mobile as well, so that you have access to that data wherever you need it. So if we look to the future, and this is the kind of the nuts and bolts of things that won't change, I think people, in order for people to really kind of make sure that they're getting the most out of the devices, that end users of the device are using them as effectively and ensuring that they are actually protecting themselves, we keep on pushing on that usability and the asset management side. So we're introducing more features to help health and safety managers make sure that their workforce are protected, introducing more features so that people that need to do calibrations know where the devices are, and just making it as seamless as possible. And one thing I would kind of add to that is that what we really want to do is add value. We're not trying to create a system here that it locks people in and gives them a very high ongoing monthly bill. We just want to help people get the most out of their fleet of devices. Battery life, this is something that we're continuing to push on. So you saw there that we got over 100 days in the detective, and we get sort of best in class performance on the wearable as well. But we're not stopping there. We see it as a really kind of key part of it. Interestingly, from a certification point of view, the regulations around batteries and how they're tested is changing. All of the new products meet the most up-to-date regulations. Any devices, whether it's from us or competitors that have existing batteries in it, in a couple of years' time will need to be compliant with the updated regulation. Always as well, you know, we operate in many different industries, and people are always looking for value. So it's a really important part of what we do here at Crocon, is making sure that we're matching kind of performance and price, and that you're getting really good value out of the devices, and that we've got the kind of just the right device for the right application. And then where we are today, we have the ambition to completely upgrade our entire portables range. That will take a bit longer. We started with the area monitor and a single gas and a dual gas, but we have quite an ambitious roadmap to come as well. So all of those things that we regard as the fundamentals of gas detection. So whether that's ruggedness, whether that's easy to use, whether that's good value for money, making sure it's just a really good gas detector so that your T90 times are good, that we're using the best sensors, all of those things that go into the fundamentals of gas detection, we're really kind of pushing on and making sure that any products that we create meet those requirements, those base requirements. So what we're going to do now is try and get a bit of feedback from everyone online. So Laura's going to jump in and we're going to do a quick survey. So what you need to do here is essentially rank your priorities. The way that you do that is in the little pane on the right. If you just drag that into the ranking, and then it should start to show up on the screen. So anyone who's online, if you can start to pull things in, that'd be great. Thank you. We'll give you a minute to do that. Oh, interesting. During the process, we really did try to kind of talk to people and find out what was most important to them. And we think we've actually covered most of the bases, but it's always good to come back and actually check the things that are really kind of hitting home. Oh, price has jumped to the top. Okay. I'll wait until the graphs settle down the top. We've got a clear winner. Price is coming up there and durability. So I'll give it a moment longer. Okay, that's great. Well, thank you for your inputs. There's a clear winner there, price. One of the things I'd say is that it's always on our mind. We need to make sure that we are getting the right point for the right product. So, and interestingly, one of the optimizations, so we've released a two sensor device, and rather than people either having to wear two individual gas sensors, which we see actually in quite a lot of applications, or we also see scenarios where people take a multi-gas, they don't really need all of the sensors and they only fill a couple of the slots. We've tried to kind of hit those niche applications where you can really, if you only need to sense two gases, you can really provide get an optimal position on that with the Duo IQ. Okay, cool. Laura, do you want to flick to the next one? Here, this is sort of like a free text entry. So if there's anything that is important to you that you didn't see on that list, it would be great if you could enter it here. You'll see the words pop out. So this is a free text entry. Just type it into the box and hit submit, and you should start to see things popping on. Okay, we got remote connectivity, compactness, change of battery. Yeah, that change of battery one, that's a good point. So we've designed the devices for serviceability. All future devices that we release will be serviceable. So the battery is connected via a connector onto the PCB. It's very easy to get in there. There's actually no screws internally. Once you've taken the housing off the Uno or the Duo, so this is the wearable device, there's no screws internally, and it's very easy to change the battery. It's very easy to change the screen. Yeah, service software. So we've got that. Mounted display, clear display. Okay, so there's a few on display there. We did discuss the possibility of having a display on top. Unfortunately, we kind of had to put a stake in the ground, and once we'd done a bit of user testing, we felt that really kind of we couldn't justify two displays. And even though we do see some need for that, that actually having it on the front of the device was still probably the optimum for the configuration. But we did consider it. Good alarm sounder. Yeah.
Jamie, I'm just going to jump in regarding the size, because that still seems to be one of the biggest other priorities. And we know that it's one of these things that, again, it's not going to change. People want devices to be smaller, but there does also seem to be a threshold of something that's almost too small and almost too easy to be lost. So I think we're just going to turn my camera back on. So yeah, we know that's important, and we know that that size piece is not going to go away. It's just finding that right balance, and that's absolute sweet spot between having a device that's the right size, so it's easy to use, but it's not easy to lose.
Yeah, and we tested the devices with people wearing gloves to make sure that you've got the single button usability piece. It's not so small that it gets lost, but it is quite light as well. I mean, one of the great innovations in this was the use of lithium polymer batteries, which is quite difficult for ATEX applications. But we found a way to do it. We found a really good supplier. And what that meant is that we could both make it a bit slimmer because you can get a better energy density, but you can also get a better battery life out of that as well. And it reduces the weight because your energy per gram or kilogram is also increased, which improves that weight size. What we did think a lot about this. We wanted it to have the right heft, but like without it being oversized. Cool. Right. Thank you for that feedback. That's really useful. It's great to hear some of those things. And like I said, even though these are the kind of, let's say, the nuts and bolts of gas detection, it's something that we feel is really important, and that we want to make sure that we retain that for the future. Oh, it's gone back to the beginning. Let me flick through. Right, so the next section, advanced sensing. And really, for us, this is kind of the core of what a gas detector is and does. And so over the years, being located in the UK, we're very lucky because there's lots of fantastic sensor companies that are based here in the UK. The people that have worked with Crocon have been actively involved in some of those sensor developments. So we always like to partner very closely with the people making the sensors, because we have some of that real world experience. They have that core scientific and materials capability to create some of the best sensors. And really the kind of the philosophy at Crocon has been to use the best sensors for the right application. There's a lot of options out there. There's a lot of pros and cons to consider with each technology. And for us, it's always been about trying to choose the right sensor for the right application. And if you look at the philosophy that we've used on this new range of products, what we wanted to do was give ourselves the maximum amount of flexibility And we came up with essentially a modular solution. So what you can see there is that's the duo. It's raised up slightly, just an exploded view to show you what's going on inside. And it can accept two sensors. Each of those sensors has got a PCB attached to it. On that PCB, that's the smart bit that does the kind of the clever interpretation of the sensor signals. It also stores calibration, which means that you can swap out those trays and the calibration stays with that. So that was a really important part for us, is making sure that intelligence stays with the sensors, and it gives you lots of really cool options in terms of how you manage those sensors and make sure that they are performing to their best, and also to make sure that we had maximum flexibility. Looking at some of the sensors, you'd be forgiven for thinking that sensors don't, the technology there doesn't move particularly fast. I would push back against that because, you know, working closely with the suppliers, we've seen lots of great innovation over recent months and years. You know, thermal conductivity, we're using the MPS sensor, which is great for detecting a range of gases. It gives you a longer lifetime and is really stable. So a fantastic technology there. Lots of people doing stuff to reduce the size. So in this set of products, we're taking reduced size electrochemical cells, which has enabled us to optimize the form factor. If you're looking for power savings, then you've got the IR sensors. And then also one of the big things from a kind of regulatory point of view is getting lead out of sensors. So traditionally the oxygen sensors used lead in them, and now we're going exclusively lead free in our portable products, which solves that ever kind of present question of when can we make the switch away from leaded sensors. It's something that people in the industry have always got together and said we need a bit of an extension in order to make sure that we can continue to sell our products. But for us, certainly within the wearables range, we feel that now we're kind of committed to using those long life lead OT sensors. And then also as well in this product range, we see a lot of demand for PID. So we're putting PID sensors into the wearables and the area monitor, which will open up loads of opportunities. And the general trends, and these will continue, so it's kind of like where we are today, but it's something that we know people will continue to work on. You've got reduced size. We see lots of new form factors coming out, people making smaller sensors, quicker T90s, quicker startups, so making sure that the sensors are ready to go in the device, getting lower power sensors so that you can really push on that battery life, and just generally longer life in those sensors. People don't want to be changing sensors every 12 months or 2 years. So we're always trying to push on that and get longer life for the sensors. So what we've done with this platform really is to create a framework such that we can take any form factor. And what this means is this protects us for the future, that we can put any sort of portable sensor that's suitable for these devices into our products. And the way that we've done that is to use a really kind of clever mechanical configuration, which means that you can put, whether it's a 1 series or a small form factor or a 4 series or a half height of that, we've created it so that you can choose the right sensor for the application. We have a good idea. So, you know, we're pretty confident that we know some of the best sensors out there on the market, and we're trying to use those sensors in the product. But what I would say as a message to everyone, if you see sensors that you want to use for an application, please honestly get in contact, talk to the team. As long as there's a good rationale behind it, then we're always open to considering either new technologies or new sensors, and specific for applications as well. As I mentioned earlier, one of the key kind of movements here is to create a really flexible two sensor module. And again, if we look to the future, what we see is much more specialization for particular applications. This is just a few combos that we see demand for. So you've got methane and oxygen, carbon dioxide and oxygen, and then H2S SO2. And these, the good thing about this is you can really target applications. And like I said, looking to the future where we see lots of opportunity and hopefully either users on the call or people that are looking to sell is specific applications that need a specific combo. We can pretty much put any combination together, and we can use the different technology. So you compare whether it's a small form factor and a 4 series or otherwise. We have flexibility there to be able to offer unique combinations of sensors. And really, not only does this give you kind of an application specific driven device, it also enables you to be really price effective in that application.
Yeah, it's going to jump in there, Jamie.
Yep.
So there's three kind of starters for 10 there for the dual sensor applications, but we're seeing more and more that there's applications, especially within food and beverage, for ammonia, carbon dioxide, ammonia, H2S, for example. Looking at refrigeration detection and combining that with modified atmosphere packaging, for example, as well, or even food quality, where you're detecting H2S, which could be a biomarker of food going off in protein-rich foods like meat, eggs, and dairy, and then ammonia for protein spoilage, which could be again another quality marker of meat and fish. So there's some niche applications out there, really, especially within food and beverage that we see at the minute. But this is cool, really, for people on the call as well, just to reach out with anything else that they've seen as well. So we'd love to hear from it.
Yeah, and we have got a question on that in a minute as well. The other thing as well is we believe that the future is modular. So we've gone down the route of having sensor modules so that you can easily swap them out. The tray is held on by a single screw, so it's easy to swap. It's plug and play. For those that do service, it doesn't take away from the existing model. So if you just want to do the standard kind of calibration, or you have a specific sensor that you just want to swap out the sensor, that's still possible. But what we're opening up here is that flexibility and usability so that you can manage a large fleet of devices much more effectively. It's really difficult getting the coordination, getting the devices back to a service center and making that as easy as possible. What we're doing here is we're giving another option that allows you to be much more dynamic in how you provide that support. So think about a person in a van. You can ship out a kind of replacement tray to their house. That all they have to do is unscrew it, plug it on, screw the screw back in, and then return that sensor to base. It can get recalibrated and sent out again for another user. So we believe the future is modular, and we've tried to prepare it for the future. This is what we will apply to any future gas detectors as well, wearables. You see it here in the area monitor. We've applied exactly that same principle there, where you've got a sensor block that's swappable that you can take out of the device. You can do it pre-calibrated if you want. It's got lots of options, and we can do different sensor blocks in the future as well. So moving beyond that, where does it go in the industry? I think there's going to be a continued trend for ultra compact and low power. That's a sort of a given. People are continuing to look at small form factors and making sure that you can get the most out of your battery driven devices. One area that we're involved in, and we've got a couple of projects where we're actually applying this. For those of you that keep up with the tech news, you'll be hearing, I don't think anyone can get away from it these days, a lot about artificial intelligence and machine learning. Um, the bit that's less talked about is the ability to deploy these machine learning models that can provide real benefits in real world applications for edge applications. And what edge means is actually deployed on devices that might be a battery powered gas detector, and using those more sophisticated algorithms for doing more sophisticated gas detection. So this is the way that we're applying it is where either for doing multiple gases with a single sensor, and that's quite an interesting project that we've got going on in the background. You might use that machine learning for doing some of the advanced diagnostics, and also just making the device itself much more selective in what it looks at. So it's quite an exciting area of development for us. It obviously is a new skill set, but we're quite fortunate. So Crocon is actually part of a larger business called Halma. Halma have some pretty good technical expertise. So as an R&D team, we're drawing down on those technical expertise and seeing how we can apply machine learning to give us advanced sensing. So that's really kind of a strong area of focus for us. You can also use it to prevent false positives as well. So if you've got something that is maybe a nuisance alarm, you can train the model over time to remove those spurious readings. And also as well, what we're seeing a lot of, and what we're trying to apply to our own products are sort of tailored sensors for some of the growth applications. We see a huge boom in battery usage. So obviously there's a lot in automotive, but as the energy grids move to a more renewable infrastructure, what they need is large battery energy storage systems to help balance the grids. And they are inherently they have some risks attached to that. So it's there've been quite a few instances of big battery installations going up in flames, and one of the areas where we see quite a lot of innovation is sensing technology that can support that. Refrigeration, because it's been a long trend, more and more use around the world, but we see that trend accelerating. So there's a lot of specific sensors targeted at refrigeration gases as well. So now our second quiz. Laura, do you want to jump in now? Right, so what you need to do here is first of all just tick any of the combinations that you have specific interest in. There is an option for none at the bottom. So these are particularly two gas combinations for the duo. We'd love to get a bit of feedback on combinations of interest to you. Oh, got quite a wide range there. That's cool. Looks like it's stabilizing. We'll give it a couple more moments. Okay, groovy. Right, we'll move on to the next one. If you, again, this is a free text input. if you have any combinations of two gases that you didn't see on that list that you'd be interested in, if you could throw those in the box, that would be fantastic. Also, as well, it's not specifically targeted at that, but if you have any particular sensors that you'd like, you can throw it in there as well. Chlorine and ammonia. Flammable and hydrogen sulfide. Hydrazine. Okay. I'll give one moment longer. Right. That's awesome. Thank you very much for that. I'll flick back to the PowerPoint. I might have to forgive me whilst I just scroll to the right point. I think it'll oh, it's not gonna. Right. Okay. So the last topic of conversation we're talking about is advanced connectivity. So before we jump into this one, what I would say is that what we've seen a massive shift in the market. I probably shouldn't mention competitors' names, but I will do. Black really changed the game with their connectivity piece, and I think what we've seen is that there's clearly a demand for really good worker safety, and I think it's an admirable thing to see that movement in the market. However, we know that there are limitations. Sometimes you're in dead spots, so it's not connected everywhere, so there can be challenges related to that. But also as well, it kind of hooks you onto a very costly platform that might not always deliver everything that you need. It might not be fully fit for purpose. So I have to give them kind of a really good plaudits that they've done a great job of creating these amazing devices, and all the people in this industry have reacted to a greater or lesser extent. The way that we're approaching it, I will talk about some of the future stuff, which is quite exciting, but the way that we're approaching it in the short term really is to come with kind of practical solutions that allow you to have insights and more aimed at kind of asset management and compliance, rather than going for that full scale connectivity out of the box. Doesn't mean we're not thinking about it, and I'll give you some of the insights of where we think we're headed with this. But as a day one approach with some of the new devices, we've gone for kind of practical connectivity. So what you can see there in the picture is an NFC tap. So all of your mobile phones have NFC built in. And what that allows you to do is do a quick kind of status check on the device. You can tap it to the device. It's the way the device actually communicates with the hub and the calibration station. And what this is, it's a really kind of neat way just to get easy insights from a device. So that's one level. It's very kind of local to the device. It has to be near to the device to do it, but it's a very simple and cost-effective way of getting information out of the device. And that was one of the keys for us, is making it kind of cost-effective. We wanted to be able to offer the next generation of connectivity and having mobile connectivity in there, but we wanted to do it in a way that was practical and usable for end users and people that don't need that full connectivity piece. So we also, on the baseline devices, this is a bit of an old one, so forgive the fact that it still says LFL on there. That were on the latest, it's got LEL. But what we have done is we've given an option for Bluetooth. We felt that for a single and a dual gas device, that actually that was the most appropriate thing to do. What that means is you can connect with a companion app. We've tried to make a really neat little easily downloadable, so you can go on the Apple App Store, you can go on the Google Play Store, just have an app, and that is it's a free companion app, and you can just pair that with your device and easily get insights. You can actually get live readings out of it. Those live readings can be beamed to the cloud, but it's more a way of just providing connectivity with a device that most people have on them. It also enables you to have on the road connectivity. What you can see in the background there is the hub. So this is the hub that does the calibration or bump test, and also can download logs and transfer data. You can connect to the hub via your mobile phone, and then you can use that if you're out on the road. You can piggyback on the device connectivity in your mobile phone. What that means is you don't get loaded with an additional data contract. Everyone's got a device that usually with them, and it just makes it super convenient. So really, in this first iteration, if we're thinking about connectivity, we're going for convenience. Moving on to the detective device. Here we focused on how we can create a local network. So the connectivity, we use a Bluetooth mesh technology, which is really neat. It's got really robust connectivity. You can have up to 25 units in a mini network. And what this does is it allows you to wirelessly pass alarms between the devices. And then to bring that all together, we have a platform. It's an online digital platform called Crocon Connect. And all of this, once it connects to the device, it can just seamlessly push that data into this asset management platform. If you don't want to use it, we also have APIs. So if you want a way of getting that data out into different platforms, then you can use the API connectivity and plug that into your own platforms. Just makes it super easy and really seamless. And again, as I mentioned earlier, we've just focused on usability. So it's about getting insights. It's not about creating a massive overhead. It's just, when do I need to calibrate devices? Who are they assigned to? Where are they? How can I effectively manage a fleet of devices? But that's where we are today. In reality, the future is a bit more sophisticated than that. So one of the things that we're looking at is that connectivity anywhere. We know the limitations. It's challenging, especially when you're working in industrial environments. So one of the things that I think is quite exciting, and it's definitely not a today thing, we're looking at least a couple of years ahead here, is that SpaceX, so those of you who are familiar will know that they've been stuffing satellites up into low Earth orbit at a phenomenal rate. I think they have something like 80% of all the satellites orbiting the Earth are Starlink satellites. The amazing thing about Starlink is it's been able to connect remote communities around the world. So once it's activated for a particular geography, then it's very easy. It's quite a simple piece of hardware, super simple to set up, and people that aren't in range of a decent mobile network or are completely off the beaten track, it enables them to connect anywhere. So it's been a real game changer in terms of satellite communications. And when we look to the future, they're actually already partnering, I think, with T-Mobile in the US, and doing direct to cell. So this means that actually you're able to do satellite messaging with your mobile phone. They've demoed kind of calls as well. But there was a really significant thing that for most people, it will have flown under the radar, which is SpaceX purchased the EchoStar spectrum. So it's not actually, they didn't purchase EchoStar, they purchased the spectrum that they use, which is the optimal spectrum for satellite communications doing direct to cell. But it also has really big implications for IoT devices. So think wearable gas detectors or the area monitor. And why it's such a game changer is, one, the cost will reduce dramatically, so the ability to stay connected, but also the robustness of it, because it's the optimum spectrum that's used for that type of application. It means that you'll be able to get decent connectivity indoors. You won't need a giant receiver attached to a device to be able to do that connectivity. So you'll be able to build satellite connectivity into lower power battery devices. And we're already in talks with a company that is a specialist IoT connectivity company, and they're working directly with Starlink in order to create a communications hardware solution that allows IoT devices to have a cost-effective connect anywhere solution. So it's something, it's not today, not tomorrow. Some of the solutions use the Iridium satellite network. The reality is that's quite an expensive and aging infrastructure. So really, if we're looking to the future and looking at satellite connectivity, then there's very exciting developments that are coming through from SpaceX and Starlink, which just means that it doesn't matter where you are in the world, that you'd be able to connect effectively to IoT devices. We're expecting dramatically improved costs. So one of the key things, as I mentioned in the earlier slides, really is providing cost-effective solutions. As it stands today, getting that real-time connectivity can be quite pricey. But what we see as technology improves, as the hardware gets better, as the IoT infrastructure evolves, we're actually getting really good price performance out of some of the newer platforms. So that's a focus for us. We do want to integrate modern technologies into our portables and make sure that it kind of reaches those applications where people do need that real-time solution, but we want to do it at a price point that makes sense for people as well. Other things we're looking at, so we want to make a closer link between the wearables and the area monitoring. In theory, they can talk to each other. We think it would be a great feature if you can pass data between those things. So not only be able to set up a local network for the area monitors, but include anybody that's wearing the portables in that. So that's quite an exciting opportunity. But also as well, create some flexible options for specific applications. We know that industrial environments are really challenging. We know that when you've got lots of metal around you, it creates difficulties for signals to pass through. So we really want to target the most painful applications and make sure that we are delivering connectivity solutions that are reliable and that make sense for the customer. And then finally, system integration. And what this kind of alludes to is we've created this really sophisticated asset management platform in Crowcon Connect. It's got an API driven. So this is protocols that means that you can link the software into other applications, but just make that connectivity really seamless as part of a larger ecosystem. A lot of customers, they'll have their central control systems. They'll have their own applications. We want to make sure that connectivity really supports customers and end applications. Cool. So we're going to move on to our final quiz. So Laura, over to you. So the way to read this is we wanted to gauge like how important it is for you and your applications. So for each of the different types of device, so the top one being the temporary area monitor, IQ, if you could rate how important real time, so think kind of live gas readings on a dashboard, how important that is to you, and then do the same for a single dual gas and also a multi-gas. Yeah. Okay, we're seeing some answers come in. Okay, looks like we've got good response, and that kind of aligns with what we thought. So we do get quite a few requests for the detective IQ. If it's out in the field, it's being deployed, you don't necessarily want to go out and have a look at it to see what the status is. That's definitely something that we're looking at. So we'll push on that. The interesting one for me is the single and the dual gas. Let's say our kind of initial assumptions have been along the lines of that it wasn't as important for those devices. So that's quite interesting. But generally speaking, we see the importance. We know that we've still got some work to do in this area. And I think, the important message that I want to get across is that the team are looking at it. We're actively doing proof of concepts in these areas. We're definitely kind of looking to that future of making sure we've got good connected devices. Do you want to flick? There's one last question, I think. If we flick onto that. Oh, yeah. There you go. Now, I'll give a brief explanation, but please, those of you that are familiar with technologies, please start clicking the button. So this is just a kind of tick box. So tick the ones that you think are important to you. As a bit of an explanator for people that aren't so familiar. So NFC and RFID, these are very basic close communications. RFID you often find in ID badges. NFC is often used for kind of payment taps, but you can do localized communication. Bluetooth, everyone knows that these days you can connect multiple devices to a mobile phone. Okay, Wi-Fi, that's an interesting one. LoRa is long range, so this is kind of think of it as Wi-Fi on steroids. You can transmit over kilometers. Okay, that's cool. So I think we'll leave there. We don't have a free form entry for this one. So if you do have any specific requests, then please do get in contact. I will. We've got a minute left, so I'll open the floor to questions. So if any of you have got any unanswered questions, then please do drop that in the chat. I'll try and whiz through. There's just a very, very final slide, which is a bit of a what to do if you want to get in contact. So hopefully we've presented of course, there's a little bit in there of where we are today because, you know, we put a huge amount of effort into developing some of these devices. We want to kind of but transmit the fact that we've, you know, not only have we tried to deliver something that's good for today, but we're preparing these products for the future. And so therefore, some of the feedback that we get from these sessions is really helpful to us because it helps guide us and think about things like, you know, what sensors we want to put in the product, what comms we want to put in the product, and other things like that. So from my side, I'll just say thank you very much for your time. Thank you for listening and joining. Yeah, hopefully you can see that we're thinking about the future and that we've got some exciting stuff coming, but also that we've managed to do a good job of delivering some, you know, meaningful innovation in the products that we have today. Cool. We'll stay on the line for a minute or so longer, but obviously some of you will jump off, but if there's any questions, we can leave it open for the Q&A. Right, I'm going to log off because I've got to jump to another one. But thank you very much, everyone. I think some from the team will stay on to answer any remaining questions. But yes, thank you for your time and hopefully you found it informative.